Here's a video to help with concepts leading up to concept 39. So we'll call it pre-concept 39, which is simplifying rational expressions. One of the things to note, rational expressions, rational is kind of like the code word for fractions. So anytime you see rational expressions, you can pretty much count that there are going to be fractions involved. So not a big deal. Make sure that anytime you're going through this video, if you need to pause it so that you can get caught up on the writing, make sure you pause it. Another good idea that I've often used is watch the entire problem being solved. Then you can pause the video to copy down the problem. That way you see all the steps in the entirety of the problem and also hear all the things that I say in describing how to solve it in its entirety. So again, fractions is just a fancy name, or rational is just a fancy name for fractions. So remember back when you're in grade school, right? You had 30 over 36. You notice both are divisible by 6, and so you get the problem reduced. It's 5 over 6, and you're done. So simplifying expressions is simply reducing them. Go on to middle school. Maybe we had x to the 5th over x to the 3rd. One of the rules when you're dividing like bases, you subtract the exponents. So x to the 5 minus 3 gives us x to the 2nd. Another way of doing this problem, maybe you saw this more in middle school, there's 5 x's on top, there's 3 x's on bottom. The 3 on the denominator cancel out 3 from the numerator, leaving 2 in the numerator, which is x squared. Okay. Maybe more problems from middle school, maybe. 5x to the 4th over 20x to the 9th. Both of those, the 5 and the 20, are both divisible by 5. So if we divide those out, 5 divided by 5 is 1x to the 4th. 20 divided by 5 is 4x to the 9th. Continue simplifying that. We have 4 x's on top. We have 9 x's in the denominator. So we can subtract those. We get 1 over 4x to the 5th because 9 minus 4 is 5. If you needed to, and you needed to line up the x's and have 4 x's on top, 9 x's on bottom to see how they reduce or cancel out, you could do that, but it's maybe a little bit better to start recognizing the patterns. Then we get into algebra 1, right? So algebra 1, we have problems starting like 10 divided by 5a minus 15. So 10 divided by 5a minus 15. In the denominator, 5a minus 15, that can be factored out. We factor out a greatest common factor, a GCF. So we're left with 5 times the parentheses of a minus 13. Okay? Because I put a little black dot right there, because the 5 is multiplied by the a minus 3, whatever is held together with multiplication, we can reduce. If it's held together with addition or subtraction, we cannot reduce that. But if it's held together with multiplication, we can reduce it. So the 5 and the 10 will both divide by 5, and we get our answer. We get our answer 2 over a minus 3. Okay, I know I talk super fast. Please remember, pause the video. That way you can get caught up. Okay, next problem. 3m plus 9 divided by m plus 3. 3m plus 9 divided by m plus 3. This is kind of the same problem that we just did on the other page. We see that the numerator has a greatest common factor of 3. So if we take the 3 out, okay, the m plus 3 cancels with the m plus 3 because in the numerator it's held together with multiplication. And so we can just simplify. That's just 3. And kind of the way to look at it, m plus 3 divided by m plus 3 is 1. And 1 times 3 is 3. Very much the same. I've used this example before. What's 5 divided by 5? It's 1. You've known that for years, right? So m plus 3 divided by m plus 3 is 1. And 1 times 3 is 3. Okay, moving on. We have x plus 2 over x squared plus 5x plus 6. The denominator here does factor into x plus 3, x plus 2. Way to do that quick in your head. The 3 multiplies by the 2 to equal 6. The 3 adds to 2 to equal 5. Okay, so x plus 2 in the numerator, x plus 3, x plus 2 in the denominator. The x plus 3, x plus 2 is held together with multiplication. That allows us to cancel the x plus 2's, and we're left with 1 over x plus 3. Okay, next problem, getting a little bit more difficult, a little bit more steps. X cubed plus 7x squared plus 6x divided by x squared plus 6x. In the numerator and the denominator, they both had a greatest common factor of x. Since those are now held together with multiplication, there's 1x in the numerator, 1x in the denominator. Those can cancel. The numerator then factors x plus 6, x plus 1, and we can reduce the x plus 6, and our answer is x plus 1. We could say x plus 1 over 1, like have 1 in the denominator, but just the same way, you wouldn't write 7 over 1, you would just write 7. So you're not going to write x plus 1 over 1, you're going to write just x plus 1. Okay, then the last problem, x minus 3 times x squared minus 25, x plus 5 times x squared minus 8x plus 15. When I look at this problem, I notice that x squared minus 25, that's important. That should stand out. That's a difference of squares. Okay, so x plus 5, x minus 5. Okay, the x in the denominator, x squared minus 8x plus 15. Okay, it's got to multiply to give me a positive, add to give me a negative. So I know that they both have to be negative signs. And then I can kind of do that. A negative 3 and a negative 5, multiply to give me a positive 15, a negative 3 and a negative 5, add to give me a negative 8. So that's kind of how I'm doing that factoring there. Okay, so I'm going to rewrite everything that I have now that it's factored out. And I start to notice I have x minus 3 in both. I have x plus 5 in both. I have x minus 5 in both. And so again, since everything canceled out, it's kind of like that 1 over 1. So our answer is just 1. So hopefully that helps. And I hope you have a great day.